So here it is RARP protocol, and it is called as reverse address resolution protocol. It is called as reverse address resolution protocol, right? And why it is called so, that reverse address resolution protocol? Because of its function like this. What is its function like this? That let's say this is a RARP software. Let's say this is a RARP software, that is reverse address resolution software, and we are passing MAC address to it. What we are passing? We are passing media access control address, MAC address. That is nothing but physical address of a device. Physical address of a device, that is 48-bit address, you know. Then it will going to generate us, it is going to give us IP address. And due to this functionality, it is called as reverse address resolution protocol. Because if we are going to pass MAC address, it is going to derive us IP address. How? Before discussing that, just write some important points. MAC address of any computer is nothing but physical address, and it is of 48 bits. Normally, it is stored on read-only memory, ROM of the device, physically. So you can say that MAC address is nothing but it is a physical address which is stored on a read-only memory device physically. And IP address of computer is nothing but it is a logical address. It is a logical address. Normally, if we talk about IPv4, it is a 32-bit address, and it is stored on a hardware of a device, and it is stored on a hard disk. It is stored on a hard disk, right? So this is first difference between MAC address and IP address. Now, let's say we are having a network like this. Let's say we are having a network like this, and in this network we are having several computers which are connected with each other. Let's say we are having several computers and they are connected like this, this, this way. Any way it could be, right? It can be anything, right? They are connected like this, let's say. So many systems are there and they are connected in some fashion. So the thing is that, let's say this particular device is diskless client. It is a diskless client, right? And here we are having, let's say, RARP server. Here we are having, let's say, RARP server. That is reverse address resolution protocol server. That is nothing but it is having RARP server is having group of disk station having IP addresses. Right? You can say that it is nothing but it is a kind of admin which is having all the information of this system, this network. Right? Now, a general form of RARP protocol will be like a general form of RARP protocol will be like this, where we are having the data, and after data we are having source MAC address. We are having source MAC address, as well as we are having destination MAC address also. We are also having destination MAC address. Getting it? So it is called as RARP request packet. It is called as RARP request packet. RARP request packet will have data, source MAC address, and destination MAC address. Now what will happen, that this destination MAC address will be broadcasted address. So it will be broadcast. It will be broadcast into that network. It will be broadcast into the network. So what will happen after broadcasting, that RARP require packet is broadcasting, right, with MAC addresses, where RARP reply is unicast, which is containing IP address. Very important point. Many time it is asked in GATE exam. RARP request is broadcast with MAC addresses. Here you can see MAC addresses are there, right? RARP request is broadcast with media access control accesses with MAC addresses, that is with physical addresses. Whereas RARP reply is unicast. RARP reply is a unicast that contain IP address. Containing what? IP addresses. Containing IP address. Getting it? This is the thing. Now, even without having hard disk, even without having hard disk, we can assign IP address to computer at runtime with the help of RARP protocol. With the help of RARP protocol, if any device does not have any hard disk, even though we can assign IP addresses to diskless devices. Diskless devices with the help of what protocol? RARP. Now that RARP request packet will be broadcasted in whatever destination MAC address we are writing here. If it is going to be get, or if source MAC address will be want to send the data to all the other devices, it will send to all the IP addresses. How it will send the IP addresses? Because RARP server will send all the IP addresses, because RARP server is having all the data of all the computers connected to it, and it will send that data to all the IP addresses, right? So basically, if any device is diskless, also that RARP is going to send, because it is going to broadcast it. And if you want to write the destination MAC address, then we can assign, and with the help of RARP server, we can ask the IP address of that particular diskless device. So thing is that particular RARP client is there, RARP server is there, and we want to send the data to other one, we can send it manually with the help of RARP server by assigning IP address. Basically used for fetching out the IP addresses by broadcasting the RARP request, and in unicasting it is going to get us fetches the IP address. But some drawback is there. Drawbacks of RARP protocol is that for assigning IP addresses in number of local area networks, right? That if we want to assign IP addresses to n number of networks, if you want to assign IP addresses to n number of networks, then you can say that n number of local area networks will be required and n number of RARP servers required for each network. So cost will be high. That is the drawback of RARP server. But I hope basically you got the crux of this is that broadcasted in RARP. I am just saying the crux of the RARP protocol, that is RARP request will be broadcasted as a MAC address, and RARP reply will be unicast and having IP address, right? So I hope it is clear. Normally, RARP is an important protocol for fetching out, you can simply say that the IP address in particular network, right? So RARP normally terms for reverse address resolution protocol, and it is very important part of, you can say that it is important part of application layer protocol, right? And with the help of such data packet, which I have already told here that this is the packet, and with the help of this it will got the thing clear, right? It means that it will fetch out the IP address for us, right? Now what we have covered we have covered HTTP, we have covered FTP, we have covered DNS, we have covered SMTP, we have covered POP, we have covered Telnet. We have covered Telnet also, right? Yes. Cool. So, okay. Let's move to the next protocol.